Hello everybody, Mr. Farnell here. I'm going to show you a way to factor difficult quadratics. So I have a quadratic here. Normally I would recommend just putting two parentheses under it and start trying different numbers. So two numbers that multiply to 12, like maybe 2x and 6x, and then two numbers that multiply to 20, maybe a 4 and a 5. And then adding some plus or sometimes some minus signs and seeing if, when you FOIL this out, if the O and the I add to this middle term. In this case, I would get 10 and 24, which is 34, not 83, so it would not work. This quadratic is a little bit difficult because this 12, instead of just factoring to 2 and 6, it might factor to 3 and 4. It might factor to 12 and 1. So there's kind of three possibilities there. Here, instead of factoring to 4 and 5, it might factor to 20 and 1, 2 and 10, or 4 and 5. And then we can also switch positions. Like maybe instead of 4 and a 5, it would be a 5 and a 4. So this one just has a lot of possibilities. So the method I'm going to show you here is for these quadratics that are kind of hard. And if you can't figure them out this way, then the method I'm going to show you will always work. So this method is called the AC method. And when I say AC, I'm referring to the number A here and C here. This is the B, right? In a quadratic, we have ax squared plus bx plus c. So the AC method takes the A and the C, so the 12 and the 20, and it multiplies them to get a product. That product would be 240. And then we take this 240 and we factor it to as many pairs of two factors as we can. So I like to just work my way down or up the numbers. So 1 and 240, 2 and 120, 3 and 80, 4 and 60, 5 and 48, and so on. You just work your way down. 6 and 40, 8 and 30, 10 and 24, 12 and 20, 15 and 16. And then if I went to the next one, it'd be 16 and 15, which then I'm going to just repeat them all in reverse. So I'd stop there. So the next step would be to find the pair of these that will add to this 83. So there's only one of those that works. It's this one. If this 83 had been negative, then I would have had to have some negatives here to add to that negative. Sometimes you might have a negative here, in which case you'd have a positive and a negative. But the general strategy always works. So we would take this 3 and this 80, and let me just write down my original again, down below here. So we would take this 3 and this 80, and we would split it up. We'd split this 83 into that 3 and that 80. So, and rewrite this quadratic. It'd be 12x squared plus 3x plus 80x plus 20. So notice how that 83 is now split into 3x and 80x. And then we would do something called factoring by grouping. So we would group these two. We would group these two. And then in this group, take out the greatest common factor of 3x. And we're left with a 4x plus 1. And then the second set has a greatest common factor of 20. And we're left with 4x plus 1. The goal here is that these two sets of parentheses match. If those don't match, then you made a mistake. These match. So at this point I have two terms, and I have a greatest common factor in both of 4x plus 1. So I will factor that out. That's 4x plus 1. And what's left is a 3x plus a 20. And this, my friends, is the factored quadratic. So this method, again, always works. If you run into a situation where none of these will add or subtract to that middle term, what that would mean is the original quadratic is prime. So let me know if you have any questions. If this was helpful for you, comment below. And until next time, have a great day.